Okay, so in this question, we've been presented with a sample of an unidentified compound. And we've been told that it contains a certain percentage of various elements by mass. So 19.51% carbon, 57.72% chlorine, and 22.76% nitrogen by mass, right? And we've been asked to work out the empirical formula of this unidentified compound. So how would we go about doing this? So the way I'm going to approach this question is effectively, there's some assumptions I'm going to use effectively to problem solve for this. So the first thing I'm going to do is I'm going to try and convert these percentages to a given mass. And the way I'm going to do that is I'm going to assume that the sample I have is 100 grams. Okay. Now, how am I actually able to reasonably do this? Well, if we add the various percentages we've got here, so 19.51 plus 57.72 plus 22.76. So if you have a go at calculating that, what you should have gone is that these numbers approximately add up to 100%, right? Not exactly, but I mean they add up to 99.99%, which is quite close to 100%. And if you do round it to, for example, 1 decimal place or to 0 decimal places, you will get 100%. Now, the implications of it not being exactly 100% is, some of these percentages are figures which have been rounded, right? So, like for example, some of these percentages have been rounded. This is why why here you've got, okay, well, it's very close to 100, but it's not quite 100, and there are some potential implications for that when we're working out the empirical formula later on, as you will see. But anyway, let's carry on with the question. So from this point, what I'm going to try and do is, okay, we've assumed that the total is 100 grams, okay, 100 grams. So this is the given mass we're working with. At this stage, the equation I'm going to work with here is the moles, mass, and molar mass equation, right? So N equals M over MR, right? So moles equals mass divided by molar mass. So what is the molar masses that we are working with in this question? And what are the masses we're working with? Right, so if we just set this up, so carbon, chlorine, and nitrogen, right? So what I'm going to do first to set this up is put together the masses, right? So as we said, we're assuming it's 100 grams, right? And we're going to just assume that this is actually adding up to 100. So let's say that is equal to, for example, to 1 decimal place, this is 100.0%. Okay, so this is what we're going to do. And in this case, for carbon, we've got 19.51. For chlorine, we've got 57.72. So this is, as it says in our question. And for nitrogen, we've got 22.76. Okay. And as we, based on our assumption, we know that all of these are measured in grams. Okay. Now we need to get the molar masses, right? Because what we want to do is divide these by the molar masses. This way we can get to the molar, the molar amounts of each of these. So how are we going to do that? Well, we're going to do that by referring to the periodic table, right? So for carbon, you probably know what the relative atomic mass of carbon is. but you know, you can refer to the periodic table. For that, it's going to be 12. So, and then for chlorine, 35.5, and nitrogen is 14, right? So divided by 12 divided by 35.5 divided by 14, right? So the moles is equal to, and then so these are effectively our molar ratios, right? And at this stage, I would invite you to have a go, try and see what you come up with when you work those out. Let me just get rid of this. Okay, so if you did that, what you should have found is that for the first one, 19.51 over 12, that's 1.62583. For the chlorine, you're going to get 1.62592. And for the nitrogen, you're going to get 1.62571. So these are the various molar quantities of each of these. And one of the things you would notice at this stage, and although I'm not going to jump to conclusions based on that at this stage, but it's quite clear if you do look at it and think, well, if I had decided to round each of these to 3 decimal places, for example, what number would I get in each of these cases, right? I'm not actually going to do that rounding at this stage, but if you did do that, I would invite you to ask yourself, what number would you get, and what might be the implications for the empirical formula? Okay, so that question can help you get a bit of an intuition of what you might expect the answer to be at the end. But I'm going to go through the process. Okay, so at this stage, what I'm going to do is multiply, I'm going to divide each of these numbers by the smallest one, right? So obviously, in terms of when it comes to determining what's the smallest one, I'm looking at the last two numbers here. So 83, no, 92, no, 7, okay, 71 is the smallest one. So we're going to divide each of these by this number, okay? So each of these is going to be divided by 1.62571. Okay, and once you've done that, what do we get? Well, for carbon, when we do that, what we're going to get is 1.00007, right? And for chlorine, we're going to get, and remember, this is the molar ratio we're looking at. For chlorine, we're going to get 1.00013. And for nitrogen, well, in the case of nitrogen, we divided 1.62571 by itself, okay? So we kind of know that based on that what we're going to get is 1. Now, as I kind of alluded to earlier on, these numbers are very similar. When it was in the 1.625, etc., etc., they were already very, very similar. Now that I've gone through the process of dividing them all by the smallest number, that becomes even more unavoidably evident that actually, yes, these numbers are very, very, very similar. And what number do we have effectively? Well, if we round them even to 3 decimal places, what do we get, right? So we get 1, right? We round it to two decimal places, we get 1. We round it to 1 decimal place, we get 1. So because of what I explained earlier, in part because of what I explained earlier, as you see, it's not exactly an exact, you know, it's not exactly 100. Sometimes it could, the numbers could actually add up to 100, but it's oftentimes these numbers have been rounded, and sometimes it's not necessarily exact. But what you're looking for is the number to be really, if they're really close to an integer number, especially in a case like this where, for example, as you can see, even to 3 decimal places, they round to an integer number. You can safely assume and effectively round them to that integer number. Okay, so in this particular case, therefore, because they're so close to 1, and 1 we can reasonably assert as being the simplest whole number ratio. So now when we're looking at the CLN, our empirical formula is, well, with the C we're going to have a 1 associated, with the CL we're going to have a 1 associated, with the N we're going to have a 1 associated. Of course, in the empirical formula we're not going to write a 1 there, right? We're literally just going to write CL N. Okay, so in this particular case, the empirical formula is CL N. So actually, you actually need DCL. But yeah, so that is effectively the empirical formula. All right.